Hey everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we saw that with two dummy variables, we get four groups and a difference in difference structure. Now, let's derive this formally using the general interaction formula. So let's start from the general interaction model that we've been using in the past video as well, where we've got y equal to beta 0 plus beta 1 d1 plus beta 2 d2 plus beta 3 d1 times d2 and then an error term e here. So this is a general interaction model and both variables here happen to be dummies. Using the general result, so the same way we did like the partial derivatives in the intuition video, we're going to have that the derivative of y with respect to dummy 1 is simply beta 1 plus beta 3 times dummy 2. Okay, so even though d1 is discrete, just a 0 and 1, you can still interpret this as the change in y when d goes from 0 to 1. Okay, so change in y when d goes from 0 to 1. So nothing is really changing conceptually from the cases that you might have seen with continuous variables or with continuous numbers in your math courses. So now let's evaluate different values of d2. Now, we know that d2 is also a dummy, so it means that we have a case where d2 is equal to 0. Let's start with that first, actually. And then the case where d2 is equal to 1. Well, we can easily see that the derivative here with respect to d1, if d2 is 0, becomes just beta 1. While the derivative of y with respect to d1 when d2 is equal to 1 is just going to be the beta 1 plus the beta 3. Okay? So in here, the effect of d1 depends on d2. And the difference between the two effects, because you only have 0 and 1 as values for d2, the difference between the two is simply the beta 3. Okay? Then how can we compute this explicitly? Well, think about it this way. Since we have two dummy variables, we're going to call y11, where dummy 1 is equal to 1 and dummy 2 is also equal to 1. In the case of y11, the model, the estimated model, is going to look as beta 0 plus beta 1 plus beta 2 plus beta 3. Okay, just as we have said. In the case of the y01 hat, well, in here is going beta 0 plus beta 2 hat. So in here, I change 0, 1, which means that d1 here is 0, while d2 is still the 1. So as you can see, although the notations for the y has slightly changed, these are the same case scenarios that we saw in the previous video. And ultimately, y hat 1, 0 here, which means like d1 is 1 and d2 is 0. This is just beta 0 hat plus beta 1 hat. And the final subgroup, 0, 0, meaning both d1 and d2 are equal to 0. It's simply beta 0. Now form the change, so the difference between y11 with y01 minus y10 with y00. Okay? We know what each and every one of these is. So if we do all of the substitutions here according to the formulas that we have gotten, then we will have beta 0 plus beta 1 plus beta 2 plus beta 3 minus beta 0 plus beta 2. Okay, this is the first one. We've just substituted. Then we're going to have here minus y1, 0, which is just beta 0 hat plus beta 1 hat, okay, minus beta 0 hat. And this is this second term here. If we simplify all of this expression, we will finally get that this is just beta 3 hat. Okay. So beta 3 is exactly the difference in difference estimator. Okay. It measures how much the effect of one dummy changes when the other dummy switches on. This is just a special case, okay, of what we saw in the intuition video for the general formula, where we had the derivative of y with respect to x being equal to beta 1 plus, if you remember, beta 3 z. Now, in here, x and z are going to be both binary. In dummy-dummy interactions, beta 3 is this difference in difference between the four groups. In the next video, we'll apply this to a worked example and interpret the coefficients step by step. So stay tuned, and I'll see you in the next video.